So, good morning everyone. I hope you enjoyed your holiday, but not me because I was busy in preparing slides for you. So now let's see what do I have to share with all of you in this talk right now. So most of you might be Vue, Angular or React.js developers, and all of these front-end frameworks follow a component-based approach. And as we know, these front-end frameworks have changed today the way our web apps look like, both internally and externally. And one interesting thing about these components is the way they interact and share the state with each other. So now let's see what is state. So state is kind of info-bounded component which controls the behavior of that component. Now the question is, why do we need state? So state helps us to keep data of different components in sync, and it also acts as a medium to communicate between different components as well. Now let's see how does different components share the state or communicate with each other in case of few level of components and when we have more nested level of components. So suppose the state of your whole application is located inside the parent component of your application, and the parent component wants to communicate with the lowest level of children component. So those of you who are using Redux know that the parent component will just pass probes to the children component, and then set state kind of function would happen, those kind of stuff. And when in the case of more nested level of components, the parent component has to navigate through all of its children components to communicate with the lowest level of children component. And that would lead us to the case of probe drilling. So now what is probe drilling? So probe drilling basically means useless passing of same data or useless re-rendering of UI. And we do not want that kind of thing to happen in our application. So that's why we need libraries like mobx or Redux, which has concept of stores. So instead of passing probes and doing all those complex things, our components can directly access that particular store and do those read or write operations. So now let's take a brief overview of how does Redux works, which is based on the architecture of Flux. And we will take the overview of Redux and MobX so that in the end we can compare both of these libraries. So the four main basic pillars of Redux are actions, reducers, stores, and state. And actions are kind of objects that tells the reducer how to change the state in the store. And reducers are those functions which produce some kind of info or state, and store contains the state of all of the components, and state, as you know, contains the info bounded component. And every time you are generating a store, you are passing some few reducers to it, and each and every time you are dispatching an action, that particular action is going to all of the reducers, and if the action type of that action matches with the reducer, then it is generating a new copy of that state and passing it to the store. And if both the previous state and the copy of the new state are different, only then the store is allowing to make that change happen in the state of the application. So Redux also has the concept of single store. So in Redux we basically have only the single source of truth, and there is no concept of dispatcher in Redux because all of our actions know where to go, and here stores are immutable. So now what does immutability and mutability basically means? So talking about mutability, you would just directly go to the store and ask for it to change its state, and that particular store would change its state for you. But in the case of immutability, each and every time you are dispatching an action, the reducer would generate a new copy of that state and pass it to the store. And if both of those copy of the state are different, only then it would allow to make that change happen in the store. And now let's see what's up with MobX. So in MobX, the four pillars again here are actions, state, computed values, and reactions. So here actions are kind of things or functions which make that change happen in the state of our application. And if we talk about state, so anything that can be mutated in our store of our application is known as observable state. And computed values are kind of functions which are derived from the state, and these are updated automatically by MobX. And so let me give an example here. So you can think of state which contains the natural numbers from the range of 1 to 100, and we have computed values, so you will just write some kind of formula or your function which produces all those numbers which are multiple of 3 from 1 to 100. And this is what computed values do. And if you talk about reactions, reactions are similar to computed values, but instead of producing some values, they are producing kind of side effects, or you can say they are giving us some UI values. And MobX also has the concept of observable and observer flow. So anything that can be mutated or changed in our state is to be wrapped inside the decorator. So basically, now what is decorator? So MobX follows the design pattern of decorators. So what does decorator design pattern says is that all those objects or functions that you are defining inside the store of your application are needed to be given some kind of functionalities. So here employee list can be mutated and is acting like an array, or you can say object. So it is given, or it's wrapped by the observable capacities, and all those components that are making use of that that state which can be mutated are to be wrapped inside the observer decorator. So each and every time you are dispatching an action, all those observable states are changing, and when that particular observable state is changed, it would just notify all those observers that are making use of that particular observer states. This is how MobX works, and that's why, just because of this observable and observer flow, MobX is called reactive. And now the thing that we were waiting for, which one is best, either Redux or MobX, or the question of asking which one is best is even valid or not. So basically in Redux we have a functional programming paradigm, while MobX follows the concept of object-oriented programming paradigm. And in MobX we have multiple stores. So here developers can separate their application into multiple modules and classes, and then they can encapsulate their logic into these classes. And all those states that are stored inside the stores are just called plain objects. And while in the case of MobX, all your JavaScript objects that are working as state are to be wrapped inside the observable capacities. And Redux follows the concept of immutability, whereas MobX follows the concept of mutability. So now let's see what do we have here. So in MobX we have a lot of abstraction, and MobX basically does not have particular rules, or you can say fashion, to do all those kind of stuff. So tracking of updations are happening automatically in case of MobX. But while in the case of Redux, so Redux provides a more control over the code to you, and so therefore you can manually track your updates. That's why Redux is called explicit, and everything and lot of stuff is happening automatically in MobX. That's why MobX is called implicit. And as we have discussed already, the observable and observer flow, that is why MobX is called reactive. And if we talk about the state, so state here in Redux is read only. So each and every time you are dispatching an action, a new copy of that state is created. So you are not doing any kind of changes in the previous copy of that state. So that's why that previous state is remain pure, and the new state is getting replaced with the previous state. So that's why everything in Redux is pure, while in the case of MobX you can do both read and write operation to the state. You are just basically doing all those changes in that previous copy of that state. So that's why in MobX everything is impure. So if we talk about actions, so in Redux actions are required. So you have to just create a separate file, define all of your actions there in the case of Redux, and you have to import those actions, that kind of stuff. But in the case of MobX, you can just directly go to the UI part and get access to the store and make that change happen in your MobX, in your store. And if we talk about Redux, so suppose you have a state tree which is very nested and it contains a lot of duplicate entries. So if you are just making any update inside the component, suppose C is getting changed or B is getting changed, so that particular level of children component would lead to all of its ancestor components to update, or you can say re-render themselves, just because of the duplicate entries or that deep particular nested data. So that's why we need to normalize our state in case of Redux. But if we talk about a MobX, you can just deeply nest your data as much as you want, because we have something known as computed values which are smart enough to know what to update and what to not. And now talking about pros, so those developers who are new to the state management system and want to learn, so I would preferably say them to go for MobX, because MobX provides a lot of reduction in your boilerplate code, provides modularity and lot of abstraction. So that's why from the learning point of view, you should preferably go for MobX. And if we talk about Redux, so working with Redux is not as simple as it sounds. So that's why Redux community provides a set of developer tools which helps those developers to kind of visualize all those complex things that are happening under the hood. So those who are working with Redux knows how much messy is to work with Redux. And if we talk about debugability, testability and predictability, so Redux provides kind of strict update logic as we have discussed, and it provides a lot of more control over the code, and there are kind of rules which you have to follow in Redux. So that's why in the case of debugability, testability and predictability, Redux exceeds this functionality in terms of performance as compared to MobX. And now if we talk about scalability and maintainability, so Redux provides kind of strict order, and all of its changes are centralized in case of Redux. But while in the case of MobX, there is no strict order. All of those mutations are scattered, and everything is impure in MobX. So again, in the case of scalability and maintainability, you should definitely choose Redux. And now, as we know, both Redux and MobX provides their own sets of benefits. So the question of asking which one is best is totally not valid. So now the question should be which library to use and when to use. So if your application is simple and it requires a rapid prototyping, and you have a small team which does not have as debugability, testability kind of stuff in their list as priority, but so you should definitely go for MobX. But if your application is complex, large, and it requires a large team which demands debugability, testability and predictability for sure, so you should go for Redux. And now we also have some few problems with Redux. So in case of Redux, you have to write a lot of boilerplate code. You have to write a lot of line of codes, and you have to do a lot of messy kind of stuff like connect helper kind of function, map state to probes, map action to probes. So we need some kind of auto generation in our code, so just to make our work easy. And Redux also lacks the functionality of tab checking, which is the inbuilt functionality of React. So the place where you are just defining your initializing your initial state, suppose you got a little bit of kind of typo, and it would just waste a lot of time for you to fix this kind of issues. So that's why we also need a library which also has the concept of tab checking. And if we talk about immutability, so immutability is just an implementation detail in Redux, and developers generally do not get a lot of benefit from it. And if we talk about code organization, so suppose you just want to add an action file in your application, or you can say in a folder. So you have to first go through multiple folders and do a lot of multiple changes in your application, and that really becomes a headache when you have to just write a lot of actions in your application or just remove them. So that's it. Now we know both Redux and MobX are not that much great, or you can say both are not perfect. So we need a library which provides the functionality of both. So for those who already knew about MobX or Redux and were sleeping in the talk, it's time to wake up, because we have something very interesting in this talk to share with you. So I'm going to discuss about mobx-state-tree, which provides benefits of both MobX and Redux. So you can say it gives you to rule to use particular, or it provides kind of particular fashion to do your stuff. And it is also powered by MobX, and it relies on the concept of trees or stores, which is same as Redux, and it also provides the functionality of initial state type or shape checking, which Redux basically lacks. And this kind of functionality is achieved by those fields and types which are provided by MST, which are of two types: primitive types and complex types. Primitive types such as types.string, types.number, types.boolean for those type checking of string, boolean, date. And MST also provides complex types like types.model for more nested data kind of stuff. And if we talk about code structure, so code structure of mobx-state-tree is really very simple as compared to Redux. And MST also provide a great concept, or you can say more interesting concepts, known as time traveling, and there is a lot of more in MST. And MST also, and as we know, MST relies on the concept of trees. So here trees are equivalent to store, and those trees are made up of three things: models, views, and actions. And as we know, models contains observable state, and those observable states are mutable. And if we talk about the type info, so models also contains the type info and that checking of type info in the starting. And you can also create many more trees, or you can also nest your model in case of MST. And if we talk about views, those views are similar to the computed values which are provided by MobX. And those views are also known as selectors in case of Redux. And if we talk about actions, so here actions are the only way to update our model. And that's it. That's how much simple is MST. And now here's the code structure of MST. So if I have to describe or explain all of the code structure of MST, so you can just divide the whole usage of MST into three parts. First is declaration of store, second is initialization, or you can say creation of store, and third is usage of that particular store in the case of in our UI part. So, and the declaration part can be further divided into three parts. So we are just going to here discuss only the declaration part. So we have as the first part our models, second part being views, and third part as actions. So in the model part, we are just declaring all those fields and type with those type state checking kind of stuff. So we have boolean, arrays, and reference kind of stuff. And in the case of views, so views are kind of functions which are giving you all those kind of stuff like array by filtering out those stuff. So here we have completed to-dos as a first function. So what is it doing? It just basically filtering out all those objects that are all those to-do items which are done and giving us that particular new list. And we also have actions. So in MST we can also just write an action like add to do, which is kind of stuff like you can see that it is just manipulating all kind of state in our store. So it is just simply pushing a new object item into the array of our store. And now let's see what does MST has to offer. So in the case of MST, your stores are both mutable and immutable. And this is very interesting because most of you might be wondering how this can be. So by the case of mutability, we all know you just can directly go to the store and make that change happen. But in the case of immutability, what is happening in our store? So you are just particularly generating a particular snapshot of that store and saving inside of your application, or you can also save to the server side. So this is very beneficial for us. So suppose you are creating an application and each and every time you are just generating or you can say making changes to your store. So you are just generating a lot of snapshots of that application of your store, and with those multiple snapshots generated, you can save them on the server side, And if the user wants to go to the previous state of the application, so you do not have to do such complex things. All you have to just go, you just use that time traveling or use that previous snapshot which we have saved on the server side. And if we talk about the composition, so composition provides, or you can say helps the developers to make more profound usage of the code. So basically, suppose you have created two stores. First store is for doing addition kind of stuff, and if we talk about the second store is this has the logic of doing subtraction. So and you want to just use third store, which should have the functionality of both addition and subtraction. So what would you do? You would just simply compose both of the stores and use that functionality in case of MST. And MST also provides a lot of lifecycle methods for us, such as pre-process snapshot for generating a snapshot before an action, and after create, after detach, before destroy. These kind of functions before creation of destroy, detachment of destroy, and detachment of model and destroying of model. And MST also provides the concept of dependency injection. We're going to discuss just in a few seconds. And MST also has the concept of utility functions. So MST provides us with utility functions like clone. So clone is basically just creating a duplicate of your model, you can say duplicate of your whole state tree. And we also have get parent, get root to navigate all those trees. And both of these functions are really very helpful when both of the stores want to communicate. And we also have get env function. So what get env function is doing, it is kind of, you can say, providing external environment to the particular store, such as you want to provide external function or external variables to your store, and you do not want to mess up with your store, with the logic of your store, so you can use getInv function. And now the concept of store communication. This is really a very interesting and very important topic in MST. So suppose your application is very large and it contains a lot of stores, and it's very complex, and your one store wants to communicate with the another store. So we need some techniques for doing store communication kind of stuff. So MST provides a lot of store communication kind of technologies, or you can say approach. So the first approach is reference of parent store. So suppose your album store wants to communicate with the language store. So all it basically would do is just get the reference of the library store, its parents, which is its parent store, and library store would get the access of the root store, and root store would give access to the language store. And in this way, album store can directly communicate with the language store, and that's it. And one con of this approach is that one of the store would end up knowing the structure of our trees. So if your application is small, then you can use this kind of approach for communicating. And the second one is actions wrapper. So you can also say it's kind of one store to rule them all. So all you just need to do is just create a particular store which has direct access to the auth store, page store, navigation store. So if you want to do stuff like logout, login, or just go to the home, so you can just directly get access to the auth store, page store, and navigation store and invoke their actions. And that's it, and that's how simple it is. But it also has a con to this approach, because action store has a lot of, you can say, access or direct access, and this is sometimes you really do not want that kind of thing in your application. And the last one is dependency injection, and this kind of approach is really cool because you have a function known as getInv, and as we have discussed, what getInv would do, it would just give access to all of the external functions, or you can say file, and you can just do access, or you can say just use those functions or variables inside your actions. So suppose or imagine a scenario where your application has a module, and that module you are using for just doing all that kind of backend stuff, or you can say authentication, and you do not want that particular piece of code to pollute your store. So all you have to do is just basically inject that particular file or function which has those functions and use later inside those actions. So in this way it provides a lot of separation in your logic. And with dependency injection you can inject anything you want. So you can even inject a particular store to the other store, and that's what makes dependency injection so much interesting. So both of the stores can directly communicate with each other. And here environment is shared per tree, and it is really useful for testing. So instead of going to the multiple folders and doing multiple changes, you can just directly inject a particular function. That's why dependency injection is really useful for testing. And MST provides a lot more. Now the final topic we are left with, when not to use MST. So MST provides us with the functionalities like snapshot, patches, interceptable actions, and fix of these issues. So all of those features sometimes, or you can say most of the times, lead us to the runtime overhead. So it kind of makes our application slow. So do not use it if your application has huge amount of mutable data, or most of the components has stateless information. So instead of using MST in those cases and making your application slow, you can go for Redux or mobx. And in the end of the day, choose whatever makes you happy. And thanks everyone for being a patient listener.